me yet again. Looking this time at sequencing basic rigid motions. So the last lesson, 7, 8, and 9, we looked at translations and reflections, rotations. This is going to be our chance to describe the sequence using any of the rigid motions that we need to. It might be one, it might be two, it might be all three of them. But we're going to figure out how to sequence these rigid motions to get one figure mapped to a second figure. So let's get right to it. Okay. With this example, you do not have to draw all of this with me because you do not have this in your binder, but I would like you to take some notes, write down the answers and the explanations. I'll try to tell you what you need to write down and when you need to write it down, but I would like you to have some notes from this so that I can see it and really so you guys can understand what we're talking about and if you have any questions for me tomorrow. So on this one, it starts out telling us, we know we've sequenced translations, we've sequenced reflections, we've sequenced both of them together, we've sequenced rotations and translations. So now that we know that we can move a figure around using these three rigid motions, we are going to figure out the sequence. Okay? But this first one, it wants you to do exactly what it says down here. It wants us to first translate along vector V, and it tells us, notice we're on a coordinate plane now, so instead of having this line drawn this vector notation for two different letters, it gives us the coordinates. It wants us to go from the point 1, 0 to the point negative 1, 1. That is the direction and the distance it wants us to go. We could also say up 1, left 2, okay, or left 2, up 1. A lot of times, I'll go ahead and show you now, the way that you're going to see this written is x, so your x coordinate, you're going to be moving it to the left 2, so it would be your x coordinate minus 2. Your y coordinate with this vector is going to be going up 1, so it would be whatever your y coordinate is plus 1. That kind of tells you how far to move each of these points. Now, that's easy to do when you're moving a point or a triangle or some kind of polygon, but it's a little bit more difficult when you have this ellipse here. So this is the time that you could really use your transparency again. We've been using that this whole time, but I do want to see this is kind of the coordinate rule that we would write for this vector here, meaning the exact same thing, distance and direction. So, and then it wants you to rotate 90 degrees around this point, negative 1, 1. So after we translate it, we would rotate it 90 degrees, and then we would reflect this line, this ellipse over line L, joining negative 3, 0, and 0, 3. So that's the line that it's going through. You can see that there. This would allow you to draw each of these very specific things. And it wants to know where would this ellipse be at after we do each of these three things. Okay, but first, which transformation would we perform first? The translation, the reflection, or the rotation, and how would you know? Does it make a difference? Yeah, I really want you to think about that. We talked in the last one that it absolutely makes a difference. We proved it in the last one. They do not always end up in the same spot if we just pick whatever order we want to. We have to do which one? Good, I hope you said the one that comes first. We have to do the one that comes first. And in this problem, the one that came first, it told us was the, go back and look, it wanted the translation first. So we first would translate it along this vector, or this distance of left 2, up 1. So we would take each of these points and go left 2, up 1, and we would redraw it. That would be our ellipse 1, or E prime, is how we would say it, or image of E. Any of those notations would work. So here's where E prime is after the translation, but we're not done. Which would we do next? We go back to that first one, you look at it, and it says that after the translation, they want you to rotate 90 degrees. So we would have to rotate that E prime 90 degrees. Now remember, if it's a positive 90, and it doesn't tell you clockwise or counterclockwise, a positive 90 means counterclockwise. So they took this E, and they went counterclockwise about this point right here. So on your transparency, you would highlight this point right here, trace your E prime, and then rotate your paper a quarter of a turn counterclockwise, and you will end up right here where it has E2. Okay, so we've done two of the sequences. We've translated along this vector V, and we have rotated it 90 degrees, a positive 90 degrees, which is 90 degrees counterclockwise. Okay, the last thing then would be to reflect. We would reflect over this line L that they gave us. So we would trace this line L, we would trace our E2, we take our transparency, we flip it. Remember, flip is what a reflection is. We make sure and line back our line L where it was traced on our transparency, and you will end right where this red one is. This right here would be your final results. That would be sequencing all three of those transformations. If you started your original here, translated along a vector, rotated a positive 90 degrees, and reflected over your line L. Now, let's try this. Now we're going to identify which of the transformations they've done. So we just performed transformations in a sequence. Now we have to identify which one did they use, or which ones did they use. So in this example right here, this is example 1 on page 52. This is that first exercise on page 52. How did they get this original triangle ABC? How would we map that onto this triangle A prime, B prime, C prime? How could we get this blue one, this triangle ABC, right where the triangle A prime, B prime, C prime would be? I want you to make that prediction. I want you to think about it. Trace it on your transparency if you need to. Which one would map it? I hope that you noticed that this would be a reflection. Okay, you would just reflect this triangle down, so you would reflect it vertically, and you would get this. But remember, we can't stop there. What do you need to do a reflection? Well, a reflection has to have a line of reflection. Our line of reflection would be what? What line did we reflect it over in order to get this A? Because the only point that actually changed places was the A, if you noticed that. The B prime equaled B, that means it stayed the same place. C prime equaled C, that means it stayed in the same place. What is the only point that moved is my A. Well, what line did I reflect A over to get to A prime? And if you notice, it was this line BC, or line segment in this case. So the line of reflection was the line segment BC, or the line segment CB. Okay? So that's how I want you to answer these. I want you to be specific. If you say rotate, well, remember, what point did they rotate? Did they rotate around point B, point A, point C, a point off of the figure? Did they rotate clockwise? Did they rotate counterclockwise? Those are the two things you need to know if they rotate. If they translated, did they translate from point B to point B prime? Remember, you have to have a vector. You have to have direction and distance. Did they translate from A to A prime, C to C prime? Which direction did they translate? You need to know that. If they did more than one, did it matter which one came first? Did they translate from A to A prime and then rotate around point A clockwise? Those are the very specific details I want you giving. If you're not sure, please answer it. Please answer something that had to do with these transformations, and then we will look at those exact answers tomorrow. I think you guys are going to do great on this. So I want you to do the rest of the problems on page 52 to 54. They're all very similar to that reflection problem we just completed. Remember, be sure to explain if they ask you. Use the vocabulary. So they rotated about point this. They rotated clockwise. They translated from A to A prime. Make sure you have that notation. Okay, look at your previous lessons if you need to. Okay, you can go ahead and try those now. We'll look at them tomorrow. So make sure that you know and are able to recall everything that we've learned in this lesson. We know that we can sequence our basic rigid motions to map one figure to another. That's what you just practiced doing on 52 to 54. You identified a basic rigid motion that mapped one figure to another. You also should have noticed that nothing about that figure changed except for the location of it. The angle measure stayed the same. The side length remained the same from the pre-image to the image, okay, or from the prime to the original. So please, please, please go back, make sure you give all of the explanation that you need, and complete 52 to 54. You're going to do great. I'm excited to hear from you tomorrow. Have a great night.